Okay, kids, after watching this video, okay, and starting the second part of this class, okay, we're going to talk about a very important event that is part of Guatemala, El Salvador, Mexico, California, and other places, and Chile too, you know? We're going to talk about earthquakes, okay? Earthquakes, kids, wow, you know? So, have you ever been on an earthquake? Have you? Yes or no? So now that you know, if you told me, if you said yes, if you have lived experience, you know, of an earthquake, oh, okay, so you know, right? It's not that really fun, okay? It's very scary, okay? So we always have to be calm, you know, and, you know, follow the directions, you know, and follow the things we need to do, all right? In order to avoid more injuries. Because, you know, when there is an earthquake, kids, we had to always look for a safe place. But always we have to act in a very calm way, okay? There are certain things and rules we have to follow when there is an earthquake, kids. So, because, you know, sometimes, you know, earthquakes, if we manage this, you know, we can survive in earthquake, especially if we are and if we look for a safe area. And we have to be used to, you know, and we had to be used to living these experiences because we live in a very strong part of the world, which this plates, you know, for example, the Caucasus plate moves constantly, and also with the San Andreas fail, all right? So now, okay, we're going to learn more about earthquake, kids. Okay, all right, now on your book, on pages 394 and 395, okay, all right, on your book. Okay, kids, let's start. Now, earthquakes. Movement of whole tectonic plates is very slow. But once in a while, a small piece of earth can shake enough to crumble buildings to the ground. Active reading. A fault is a break in Earth's crust, where rock on one side can move in relation to rock on the other side. As plates move, pressure builds up along the fault. When the pressure becomes too great, the rock on one side of the fault suddenly snaps free and slides past the rock on the other side. This release of energy and shaking of the ground is called an earthquake. Okay, look at this. The fault, focus this on the picture. Seismographs are used to record and predict earthquakes. Okay, let's move to the other page. The point inside Earth where an earthquake begins is called the focus. The energy from an earthquake travels away from the focus in waves. When the energy waves reach the surface, the ground shakes. The point on Earth's surface directly above the focus is called the epicenter. Earthquake motion is most severe at the epicenter. Smaller waves of energy occur near the focus before an earthquake. The tremors may not be felt at the surface, but a device called a seismograph can graph them. Scientists can use a seismograph to predict if an earthquake is likely to occur. There is no way to prevent earthquakes, though, to avoid injuries during an earthquake. Avoid buildings, bridges, or other structures that are likely to fall down. Earthquakes can be dramatic and can cause great damage to build structures. Okay, look at the pictures, kids. When the ground at a fault shifts, it moves structures built on it. Okay, so now look at this. Compare what the motion of the ground was probably like during these two earthquakes, as shown from a seismograph. Okay, so they have different intensities. Okay, as you can see with the movements of this seismograph. Okay, one is stronger than the other one. And we here see the epicenter and the energy waves. Okay, so now on the other page, 396 and 397, measuring earthquakes. How do scientists describe the strength of an earthquake? Do they measure the size of its energy waves? Do they figure out the total amount of energy it produces? They do both. Active reading. An earthquake's magnitude is the amount of energy it releases. The Richter scale measures the magnitude of earthquakes on a scale from 1 to 10. The scale uses the size of waves on a seismograph to determine an earthquake's strength. An earthquake that measures 2.0 on the Richter scale is too mild to feel. About 8,000 earthquakes measuring below 2.0 on the Richter scale occur every day. Can you imagine this, kids? Wow. An earthquake in Italy in 2009 caused extensive damage. Look at the picture, kids. Okay. Presidential Palace, Haiti, before and after. Okay. These two pictures are from a very strong earthquake which happens in 2010. And it had a 7.0 Richter scale, which was really strong, and destroyed most of the structures, in Haiti that year. Okay, so look at on these two pictures, the magnitude, the earthquake location, and year. So the strongest earthquake in history that is being recorded, or that is known, it happened in Chile in 1960, which was of 9.5. Then we had Kuril Island, Russia, 2006, 8.3. Sichuan Province, China, 2008, 7.9. Haiti, 2010, 7.0, like the one I told you, on these two pictures. Then another one in Chile, 2010, which was of 8.8. In Japan, 2011, 9.0. By the way, Chile and Japan are, on these two countries, there are always lots of earthquakes every year. And they also have the strongest earthquakes too in history. Okay, each 1 point increase on the Richter scale means an increase in strength of about 31 times. An earthquake measuring 6.0 or higher on the Richter scale can cause heavy damage in populated areas. Earthquakes measuring 6.0 or stronger occur about 120 times per year. The Richter scale was developed in 1935. Scientists have since developed a more accurate way to measure the magnitudes of larger earthquakes. The moment magnitude scale, MMS, uses a mathematical formula to calculate the total energy that an earthquake releases. The moment magnitude scale also assigns numbers between 1 and 10. In January of 2010, an earthquake measuring 7.0 on the moment magnitude scale caused catastrophic damage to a densely populated area in Haiti. Okay, look at this, kids. Explain which of these locations will experience greater earthquake damage. A city or the countryside? Okay, I think it's very obvious which location will have more damage on an earthquake. Okay. All right, kids. So now, after talking about earthquakes, so what is the lesson of today? Well, about the Earth's crust. But we have also learned about plate tectonics, earthquakes. And that we know also that we have to learn to live with this, with these movements of the Earth, okay? But now I'm so happy because I'm going to talk about something I really love. And it is part of my life. And I have a passion for this, And we are going to learn about volcanoes. Yes, volcanoes, kids. I love volcanoes, if I were not a human, I would like to be a volcano. Yes, they're my patient. I love them. Okay, but anyway, all right. Okay, so volcanoes, kids. So, all right. One of the things that I really love about Guatemala? Yes, it's because of this. Because of the volcanoes, kids. Wow, you have such a beautiful country. Guatemala has beautiful volcanoes, kids. And it has hundreds of them, and mountains too, But I am very, very happy because I have hiked so many volcanoes here in Guatemala. And you know that there are 37 official summits. 37 official summits, named by the Hiking and Climbing Guatemalan Association, here in Guatemala. There are 37 summits, official summits. And I have hiked 28. So I need to complete the 37 official summits. And after I do this, 9 summits that I need, that are left for me to do, I will already finish, this great adventure, all right, of hiking volcanoes in Guatemala, which I really love. Okay, but anyway, so let's continue. Well, do you know, kids, that you have in Guatemala, there are 3 active volcanoes, which are really beautiful. Okay, so you know, one is Pacaya volcano, the other one is Fuego volcano, and there is another one, which is Santiaguito volcano, which is near where we are in Shela, you know. Santiaguito volcano is next to Santa Maria volcano. So these three volcanoes, Pacaya volcano, bing, Fuego volcano, bing, and Santiaguito volcano, bing, are the active volcanoes you have here in Guatemala. Alright, I have already hiked Pacaya and Fuego volcanoes. And I have seen them explosions, you know, of lava and beautiful fires, you know, rocks fires. Oh, great. Okay, so now let's learn more about this, okay? Volcanoes. The heat and pressure in Earth's interior are intense enough to melt rock. Does that liquid rock ever make it to the surface? Yes, it does. The liquid rock below Earth's crust is called magma. At boundaries where plates are either moving toward each other, pulling away from each other, or at hotspots in the middle of plates, openings in the crust can occur. A volcano is an opening that allows magma to reach Earth's surface. Lava is the molten rock that erupts from the volcano along with ash and hot gases. The shape of a volcano depends on how that volcano erupts. Some volcanoes erupt explosively, spewing lava, ash, and gases high into the air. Other volcanoes erupt with a slower, steadier flow of lava. Okay, look at the picture, kids. Over 450 active volcanoes line the rim of the Pacific Plate. Imagine only the Pacific Plate. The belt is called the Ring of Fire. Yes, that is how it is called, the Ring of Fire, kids, which goes all of it. So look at the picture. It goes all around the Pacific Plate. Okay, so look at the picture of a lava erupting. Okay, let's move to the page 399. Non-explosive lava flows form shield volcanoes. Broad sheets of lava steadily build up to form the wide lobe shape of a warrior's shield. The island of Hawaii is made up of 5 shield volcanoes. Explosive eruption forms cinder cone volcanoes. Lava explodes into the air and quickly hardens. The fragments fall and collect to form the volcano's steep slope. Paricutin is a cinder cone volcano in Mexico. Alternating types of eruptions form composite volcanoes. Explosive eruptions produce the steeper slope and liquid lava flows. Cement that fragments in place Mount St. Helens in Washington state is a composite volcano. Alright, look at these 3 pictures, kids. Okay, so as you can see how the lava and the explosions in volcanoes, you know, happened. And the first one was in Hawaii, the one in the islands of Hawaii. The other one is, okay, in Mexico. And the other one is the Mount St. Helens in Washington state. Okay, so now this question. Which type of volcano does the photos show? Describe the formation process. Well, they formed a cone cylinder. Okay. Alright, kids, now that we have learned more about volcanoes, alright, let's move to page 400, 401, and 402. And you know what? Yes, it's zoom it up. Right, kids? Yeah, we have it here. Look. Zoom it up. Brain check, and it's like concept. Okay, so and this 3. Alright, so you know what to do, kids. Okay, and remember, all these words which are written on yellow here, you have to write them down at the beginning of this lesson. Alright, here on this part. Okay, so always do that. Okay, kids. I really hope you like this class about, you know, the crust earth, plate tectonics, earthquakes, and volcanoes. All right? And to finish this class, kids, we are going to watch a video about volcanoes, kids. Okay, so hope to see you soon. Alright, study, kids. And remember, tomorrow, Tuesday, we have grammar class. Okay, so thank you very much for watching my video and see you soon. Okay, kids. Mwah. Love you. Bye. Zoo.